Okay, here estimation of degradation model is by three methods: estimation by image observation, estimation by experiment, estimation by modeling. These are also called as blind deconvolution. So that means the process of restoring the images based on the estimation of degradation model is nothing but blind deconvolution. So okay, now the first one is estimation by image observation. So okay, now okay, here this is input image and this is the actually input image, but here the acquisition system gives the image like this. What is that? Degraded image. User easily say this one is the degraded image. So now here he has to restore the original image from this degraded image only. He does not know the what is actual original image. So here so we know that this one is nothing but degraded image is represented like g of x comma y. G of x comma y is nothing but f of x comma y convolved with h of x comma y. Right? This is the f of x comma y. So actual input image, and that is degraded by certain degraded function. So that's why here degraded function is represented as h of x comma y. Now f of x comma y that is convolved with h of x comma y is nothing but g of x comma y. Here ignore the noise function. So now g of x comma y, this is the degraded image. So now here take some small sub image here, small sub part here, this one. Let that one is nothing but gs of x comma y. Let it be gs of x comma y. So now here apply DFT, apply the DFT. For this small gs of x comma y, apply the DFT. Now we can get gs of u comma v, gs of u comma v. Right? So this one numerator, it's okay, gs of u comma v. And then, so this is the sub image, gs of x comma y. So okay, here based on certain restoration technique, restoration process by estimation. So just we are estimating certain function. So restoration process by estimation. So here use certain restoration filter, then get the restoration filter output, that is denoted as reconstructed subimage. Reconstructed subimage or restored image. It's okay, reconstructed subimage. That is indicated as fs cap of x comma y. Now apply the again DFT to this. Now fs cap of u comma v is obtained like this, right? From this fs cap of x comma y. Take the ratio between these two, gs of u comma v and fs cap of u comma v. So okay, of course you know that g of u comma v is actually from the block diagram we explained g of u comma v is nothing but f of u comma v into h of u comma v. G of u comma v divided by h of or f of g of u comma v divided by h of u comma v is nothing but f of u comma v. G of u comma v divided by f of u comma v is nothing but h of u comma v. Right? So that means here is a gs of u comma v from this gs of x comma y, and from this, so we have the fs cap of u comma v. Take the ratio, then you can get certain image that is represented as hs of u comma v. That is our h of u comma v. Estimate like this. Okay, like this. That is nothing but estimated transfer function of h of u comma v. That means here, how can we estimate the degraded function h of u comma v? So here take one image, take this part here, small part, improve that image by using certain technique. Improve that image by using certain technique. So that technique is said to be here restoration technique. Then that image is here called as fs cap of x comma y, then convert that one to the fs cap of u comma v, and then take the ratio of these two. So here from this equation, of course you know that g of u comma v by f of u comma v almost equal to h of u comma v. So from that knowledge, so this ratio almost almost gives the result. What is that? H of u comma v. So in this way we can estimate the transfer function of degraded function. This case is used when we know only g of x comma y and cannot repeat the experiment. Right? So okay, this is one method, that is estimation by image observation. So that means here I am observing this image. Based on that, I just improve the image based on the user. What is that? User intention. Based on that, he improves that image based on certain technique. Right? It's okay. Right. So in this way, we can estimate the, what is that? H of u comma v. So now coming to the another one, estimation by experiment. The first one is estimation by image observation. Next one is estimation by experiment. It is used when we have the same equipment set up and can repeat the experiment. In the previous case, we cannot repeat the experiment. Actually, by observing particular image, we can do that one. Right? So here, due to certain doing some experiments, then repeated experiments, we can conclude. So what is the estimated transfer function of degraded system? It's okay here to this particular in this. So here consider one system. So that is h of x comma y or h of u comma v. So here apply one input impulse image. Input impulse image. So right. So that is said to be here del of x comma y. So take some magnitude a into del of x comma y. So that is applied to the certain system. System gives certain output. System gives certain output. So here that is said to be g of x comma y. G of x comma y. Apply the DFT here and also apply the DFT here. So now for this the DFT is a. For this the DFT is g of u comma v. So now here h of u comma v is nothing but output by input in frequency domain. So system function is nothing but output divided by input. So g of u comma v by a. So here h of u comma v is nothing but g of u comma v by a. In this way we can estimate the h of, that means here degraded image is there. So if I acquire this particular image by using certain system, it gives certain degraded image. So here this degraded image is not the exact image. So here due to the certain problem in system, then only I can get that degraded image. So here to find out that system failure, so where here the particular drawback is there, to find out that one. So here for a same system, if you give this type of image, so it should give the same image, but here it should give the same input image, right? So like this, but here the system output is not exactly like a input impulse image. That means this is a degraded image. Am I correct? This is a degraded image. So okay, here what is the estimation of degraded function here? So to find out that one, right, I am using this method like this. Right? So h of u comma v is nothing but g of u comma v by a. Right? So now based on this, I know the g of u comma v from g of x comma y, and of course this is the constant. Based on this, I can easily find out h of u comma v. Based on h of u comma v, From the equation, what is that? This one. From the equation, what is that? Based on this g of u comma v. So that is actually fed to the restoration filter. Then I can get the f of x comma y original image based on this h of u comma v. Based on this h of u comma v. That means here degraded image g of u comma v is there. Restoration filter also should be designed. Then I can get the f cap of x comma y. So how can I design the restoration filter? Based on this degraded function. Since g of x comma y is affected due to this h of u comma v. So now if I know the particular h of u comma v, then I can easily build the restoration filter. Then I can get the f cap of x comma y, that is the replica of the f of x comma y. So this is the actual story here to know this one, right? So okay, estimation by experiment. In this way, so the known input images and with the known for that we know the output. So now we can easily find out the system degradation function. Now here the next one is estimation by modeling. So here this one is used when we know physical mechanism underlying the image formation process that can be expressed mathematically. So okay, here if you see this one, this is an original image. Suppose some severe turbulence is there and here mild turbulence is there, low turbulence is there. So these three are degraded images. These three are degraded images. Suppose if I know the actually suppose this is an original image, but due to something due to this atmospheric turbulence, so I may get some modification in this image. So here turbulence estimation, I can easily estimate this turbulence by using this formula. This formula is nothing but e power minus k u square plus v square 5 by x 5 by 6. Based on the k, if I change the k values here, for different k values I can get like this, right? If I model the particular degraded function, so if I estimate this one, right? So based on this mathematical equation, then if I get this image, I can easily get the original image from this degraded function, right? So okay, by mathematical equations, so those are developed from the actual pre-observation. So now here I can easily estimate the degraded function. So here is just an example for motion blurring. So here also from particular analysis, so not an important to you in the BTech point of view. So here based on that motion blurring from particular observation, and we can apply certain analysis on that. So here, so I can get the mathematical equation like this, right? So after solving particular h of u comma v, so based on certain methods, so now this one is the equation. Based on this equation, right? So here this is a blurred image. So here a, b is 0.1, t is a 1. So here, so now here I can easily find out the h of u comma v. So this is due to this motion blurring. So this is an equation. So in this equation, if I substitute this one, so you can get like this image. So now from this h of u comma v, I can reconstruct this original image from this blurred image, right? Okay. So that's it. That is nothing but estimation by modeling. So these three are here different methods to estimate the degradation model. These are also called as blind deconvolution. Thank you.